Okay, we are back for a second day of exact values. So I'm going to title this More Exact Values. That's a creative name. And I told you in class today that I was going to try and keep this between 8 and 10 minutes. I really want to jump straight into some examples and show you what we're going to be doing. You'll see how this is different than yesterday's assignment. So the first example I want to look at for you is 5 times the cosine of 10 pi over 3 minus 3 times the sine of 19 pi over 6. So you can see how this is different from yesterday. I have a coefficient in front of this cosine. I've got a coefficient in front of this sine, and I have to end up subtracting these two things. So the first thing I'm going to do is I have to figure out the fraction for the cosine of 10 pi over 3. So let's just jump straight into that. We have to figure out where 10 pi over 3 is. Now 10 pi over 3, let's think about this. You could do some conversions, but I want to think about this in terms of fractions. I'm going to call this 0, and I'm going to call this not 1 pi, but I'm going to call it 3 pi over 3. That's 1 whole pi. And then if I go all the way around to a full circle, instead of calling this 2 pi, I'm going to call this 6 pi over 3. And so working through here, this would be 3 pi over 3, 6 pi over 3, 9 pi over 3, and how much more do I need to go? I need to go to 10 pi over 3, so I need one more pi over 3 rotation. And what is that in degrees? Somebody out there said it. Maybe you didn't, I don't know. But anyway, it's 60 degrees. And so my reference angle right here is a pi over 3 or a 60-degree angle. So I'm going to come down here off of all of that spiral-looking thing. And I'm going to draw that triangle. That triangle right here, I'm going to pull that off of that graph, and I'm working with it right here. So again, we went 3 pi over 3, 6 pi over 3, 9 pi over 3, so we need one more pi over 3, so I am dealing with a 60-degree reference angle. And then this little angle down here is a 30-degree, and then of course we've got a 90-degree box. And our base reference angle, we would put a 1, our base 30, 60, 90, we would put a 1 across from the 30. But look at where this is. We went on the negative x-axis. So instead of putting a 1, I'm going to put a negative 1. And then across from the 60, we usually write a square root of 3, but notice that we went down there. So I'm going to call that negative square roots of 3. And then, of course, on the hypotenuse is what? It is a 2. Alright, so to find the cosine of this reference angle, it is negative 1 over 2 because cosine is adjacent over hypotenuse. So this is going to be negative 1/2. I'm going to write this over here, what I have so far. 5 times the cosine of 10 pi over 3, which we just figured out is negative 1/2. That is not a 2. So we're going to have 5 times negative 1/2. I'm really struggling with my marker today, but I guess you can hear what I said. So, alright, the next thing I need to do is find the sine of 19 pi over 6. And I'm going to draw another triangle for this. And then instead of labeling this in thirds, I'm going to label these as 6s. So this would be 0, and then one rotation this way, or 1/2 rotation, 180 degrees. Instead of calling that pi, I'm going to call that 6 pi over 6. And then if I were to go all the way around to 2 pi, this would be 12 pi over 6. And I need to go to 19 pi over 6, so let's keep thinking about this. Let's rotate through here. 6 pi over 6, 12 pi over 6. Now if I go another half rotation around over here, now I'm at 18 pi over 6, and I want to get to 19 pi over 6. So I need to go one more pi over 6 rotation. So what is this reference angle then? It's like Blue's Clues. Yes, somebody said it. It's pi over 6 right here. So I'm going to pull this triangle down here so that we can work with it. And this reference angle, pi over 6, is a 30-degree angle. And then that makes this a 60. And then this is a 90. Alright, so how we're going to label this on our 30, 60, 90, we put a 1 across from the 30, but look where it's at. It's in quadrant 3, and we went, this is going down here, so that's a -1. And across from the 60, we put a square root of 3, but we went left, so that's a negative square root of 3. And of course, the hypotenuse is a 2. So the sine of this reference angle is opposite over hypotenuse, and look, we get -1/2 again. So I'm going to say minus 3 times the sine of 19 pi over 6, which worked out to be -1/2. Now all I have to do is some integer work. I guess this is back to some 7th grade math. So let's see what we have here. 5 times -1/2. I'm going to jump. I guess I can do it right here. 5 times -1/2 is -5/2. Of course, because we can just put a 1 underneath that. We're multiplying with fractions. Then minus 3 times -1/2. This minus and that negative make a positive, so this becomes plus 3/2. And miraculously, we have the same denominator, so I can just add those numerators up, and that becomes -2 over 2, and that is -1. That's fairly interesting. -1. All right, let's extend this page, and let's do another example here. Let's do cosecant, we haven't messed with that one very much, squared of 2 pi over 3. And then plus the tangent squared of 7 pi over 6. And this is some weird notation that you probably have never seen before. And this is a weird place to put the squared. Anytime you see this notation, you need to think about this as the cosecant of 2 pi over 3. And all of this is going to be squared. So once we find that fraction, we're going to square that fraction. And I guess just for the notation, this looks a little bit cleaner than all the parentheses here. It's just traditionally with trig, if we want to put an exponent and we want to square the value of the trig function or cube it, we just put the exponent on the trig name, and we don't put it in parentheses like this and outside the parentheses. And for the same reason, we need to think about this as the tangent. I'm fighting with my pen here, sorry. Of 7 pi over 6. My pen is really not responding very well, squared. So I apologize about that notation, but you see what we have to do. Alright, so let's go ahead and find the cosecant of 2 pi over 3 by finding our 2 pi over 3 angle. So let's draw that. 2 pi over 3, we did this yesterday, and some of you might be getting used to this. 2 pi over 3 is over here in quadrant 2. And I'm going to drop my altitude, and that leaves me a pi over 3 reference angle, which is 60 degrees. And then the little angle up here is 30, and I am not happy with this, so we're going to back that up. Alright. Apologize about the little delay there. Draw that again. 60 degrees here. It's not the best, but okay. And there's 30 degrees there, and this is a right angle. Alright, across from our 30, we're going to put a -1. And of course, it's negative, we went left. Across from the 60, we're going to put a square root of 3. And then on the hypotenuse, we put a 2. Now, we have to remember, what is cosecant? Cosecant is the reciprocal of Anybody remember? And this is really weird because it should be the reciprocal of cosine in my opinion, but they didn't ask me. It's the reciprocal of sine. So what I'm going to do is I'm going to find instead of doing opposite over hypotenuse like sine would tell me to do, I'm going to find hypotenuse over opposite from here, and that would be 2 over the square root of 3. And that is all squared. Okay, let's find the tangent of 7 pi over 6. So I guess I'll come down here. And 7 pi over 6 is an angle over here in the third quadrant. And this reference angle is a pi over 6, or a 30-degree reference angle. So that makes that 60, and this is 90. I've spent a lot of time in quadrant 3 today. Across from the 30, we're going to put a negative 1. Across from the 60, we're going to put a negative square root of 3. And on the hypotenuse, we're going to put a 2. So the tangent is opposite over adjacent, which is negative 1 over negative square roots of 3. And then we're going to take that and square it. Alright, so what we've done is we've found our two trig functions, and now we're going to do the other computations, which involve squaring those values. So when you square a fraction, all you have to do is square the top and square the bottom. So 2 squared is 4, and the square root of 3 squared is 3. Let's do this other fraction. Now in this other fraction, these two negatives become a positive. So I'm just going to square the 1, which is a 1, and square the square root of 3, which is a 3. And now, luckily again, I had common denominators. So I add the tops up, and we get 5/3. And that should be enough for you to start tomorrow's lesson. We're going to have a worksheet over more exact values, and really the only difference is we're going to have those coefficients and maybe some exponents.